Hi, I'm Julius. In this video, we're going to take a super quick look at the Prometheus monitoring system. We're going to talk about what Prometheus is, what the system architecture looks like, and what some of the main features are that make Prometheus so useful. So, what is Prometheus? It's a metrics-based monitoring system that helps you ensure that your systems and services are healthy and behaving well. It gives you a whole tool chain of libraries and server components that allow you to expose metrics from the things you care about, collect and record those metrics, and then do useful things with them, such as alerting, dashboarding, ad hoc debugging, or automation. Aside from that, Prometheus is written in the Go programming language, and it's hosted by the Cloud Native Computing Foundation under an open governance. All right, with that out of the way, let's have a look at the system architecture of a basic Prometheus monitoring setup. The big box in the middle here is the Prometheus server. Depending on your needs and the size of your organization, you can run one or many of these. Now, Prometheus is a pull-based monitoring system that pulls or scrapes metrics over HTTP from a set of systems and services that you want to monitor. In Prometheus lingo, we call each of these monitored endpoints a target. These targets can either be your own services and applications that you can directly instrument with Prometheus metrics, for example, using one of the official client libraries, or if they're a third-party system like a database or a Linux host or anything else that doesn't expose Prometheus metrics natively, you can run a so-called exporter process next to that target to allow Prometheus to pull metrics through that exporter. Now, you can configure the list of targets to be monitored statically in your Prometheus configuration file, or Prometheus can also talk to a wide variety of different service discovery mechanisms like DNS or the Kubernetes API server to automatically discover all the targets that it should monitor on an ongoing basis. Prometheus then pulls metrics from all of its targets on a periodic basis and builds up a view of the metrics over time on local disk in its time series database, also called the TSDB. You can then use that collected metrics data either to generate alerts, which are routed, aggregated, and dispatched through a separate component called the Alert Manager, or you can query the data externally, either through Prometheus' own web UI, a dashboarding tool like Grafana, a query builder like PromLabs, or any other tool. You can also optionally configure Prometheus to forward the samples that it collects to a remote storage system or processing endpoint that might have totally different trade-offs and characteristics than Prometheus' own local storage implementation. To understand Prometheus even better, let's have a look at its core features: the dimensional data model, the metrics transfer format, the query language, integrated alerting, and support for service discovery. First, let's talk about the data model, since everything else in Prometheus depends on that. So on a fundamental level, Prometheus tracks and stores time series. Time series are numeric values that change over time and that are sampled at specific points in time, usually whenever Prometheus pulls metrics from a target. There's two questions that come up here. First of all, how do we model a single sample and which values can it take? And secondly, we want to be able to track and query multiple time series at the same time, so we need a way to identify each series and tell them apart from each other. So in Prometheus, every time series has an identifier and an ongoing stream of samples that gets built up over time over multiple successive scrapes. Those samples store the actual numeric values belonging to a time series. Now, each time series is uniquely identified by a metric name and a set of labels. The metric name is the aspect of a system or service that you're measuring. This could be the number of HTTP requests that a server has handled since it started, a temperature, memory usage, or anything else that you can track numerically. The labels are key value pairs that allow you to partition a metric name into many individual time series so that you can track in more detail where something is actually coming from. Now, Prometheus automatically attaches some of these labels to tell you which targets these time series came from. Those labels are called target labels. But a target itself can also choose to split up a metric by any other labels. For example, an HTTP server might split up its request counters by the HTTP method and the status code. Okay, let's have a look at the sample stream here. Each individual sample consists of a timestamp and a value. The timestamp is usually the time of the scrape and is stored as a 64-bit integer timestamp in milliseconds. The sample value can be any valid 64-bit floating point number. Now, this is going to change just a little bit in the near future with the upcoming addition of a native histogram data type in Prometheus, where a sample value can actually be a full-blown histogram as well. But today that's not quite officially part of Prometheus yet. Now, in order for Prometheus to be able to pull metrics from a service you care about, that service needs to expose an HTTP endpoint that serves a text-based metrics transfer format that Prometheus understands. Here's an example of what two simple metrics look like in this text-based format. Each line that's not a comment represents the current value for a given time series, along with its metric name and labels. So, for example, you have an HTTP request counter here that is split up by the status code as well as a metric that tells you the current number of open file descriptors in the process that's being monitored. What's important to understand here is that each scrape or pull only transfers the current value of each tracked series. So the sampling frequency is completely up to Prometheus and there's no history being transferred here. The idea behind this text-based metrics transfer format is that it's supposed to be as easy to generate as possible. So this makes it possible to get Prometheus metrics out of almost anything, even if you can't use a dedicated client library for tracking and exposing metrics. And since Prometheus is pull-based, you can also manually navigate to any metrics endpoint of a target in the browser to view the current state of all of its metrics. After collecting and storing all of these metrics, you'll probably want to do something useful with them. For that, Prometheus comes with its own PromQL query language, which allows you to query and process the collected data for alerting, dashboarding, ad hoc debugging, or any other use case. PromQL is really geared towards time series-based calculations that even allow you to perform complex arithmetic between entire sets of time series. We won't really go into all of the details here, but let's just have a quick look at a few simple examples of what PromQL allows you to do. Imagine you had a counter metric named HTTP requests total that told you how many requests a server has handled since it was started. And it's split up by a path label, a method label, and a status code label. Now, you could query for the current value of all time series with that metric name, and where the status code was 500, by just writing the metric name itself with a set of label matches in curly braces appended to it that constrain which time series should be selected. To get from an absolute count to a rate of increase, you could then use the rate function over an averaging time window of 5 minutes to see how many of these request errors are happening per second. You can now also use dimensional aggregation operators to aggregate away some of the label dimensions and keep only certain labels. In this case, we're summing over all the individual rates and throwing away all labels except the path label. This gives you a per path total request rate. Now, if you wanted to know all paths that had a 500 error rate larger than 5%, we could use a binary division operator to divide the per path error rates by the total rates for equivalent paths, multiply the resulting ratios by 100 to get to a percentage, and then use a filter operator to only return those paths with an error rate over 5%. You could use this for alerting, for example, and get an alert for each problematic path. Now you can do way more with PromQL, but these were just some introductory examples to give you an idea of what the language looks like and what it can do. One really cool thing about Prometheus is that it bases alerting on the same PromQL query language that you would use for dashboarding and other use cases. So to make Prometheus detect and alert on problems in your infrastructure, you can configure it to load a set of alerting rules from files, with each rule providing a PromQL expression and a set of metadata fields about the alert. This example alerting rule consists of an alert name, the PromQL expression that forms the heart of the rule and that determines if anything is wrong, as well as a few other YAML metadata fields that allow you to add a time tolerance and additional information to the resulting alerts. Finally, let's talk about service discovery integration. Since Prometheus is a pull-based monitoring system, it needs to know which targets it should monitor, how to fetch metrics from them, and how to identify each of them correctly so that it can attach the right labels to the pull time series. Now, you could manually configure a static list of targets in your Prometheus configuration file, but that becomes really infeasible in many of today's large and dynamic computing environments, where both machines and service processes just come and go all the time. Fortunately, Prometheus can automatically discover and update its list of targets for you using a variety of service discovery mechanisms such as DNS, Kubernetes, Consul, and others. You can even build your own file or HTTP-based discovery integration if Prometheus doesn't support the one you need out of the box. Alright, I hope this video gave you a good idea of the basics of Prometheus. In my next videos, I'll dive deeper into the topics we covered today, as well as discuss best practices, current developments, and other Prometheus-related topics. If you found this video helpful and want to learn more, be sure to check out my self-paced training courses at training.promlabs.com. These courses go into more depth and cover a wider range of topics, from the basics of Prometheus to advanced features and integrations. So if you're looking to take your Prometheus skills to the next level, check them out today. Thanks for watching, and I'll see you in the next video.